want to use your notes as you're working through the multiple choice, you can. Just know that when we have your quiz next week, you will not have your notes. Okay, so like we talked about last time, the whole point of this class is to get you prepared for pre-cal, which then prepares you for calculus, right? That's why we're using this curriculum, Mark Sparks curriculum. So what he does is he uses the AP format for all of his multiple choice and free response questions. So today we're just learning about that, doing some math while we do that, okay? So the first question, what was the solution to the equation, that long, ugly equation? Okay, and the correct answer was D, x equals -3/2. Would anyone like me to work that? Going once, going twice. Okay. Number 2, which of the following values is or are solutions to the equation 3x plus 14 equals 2 times x plus 7 plus x? Okay, the correct answer was D again. 1, 2, and 3. Why was it 1, 2, and 3? Infinitely many solutions. At some point, you should have 3x plus 14 equals 3x plus 14. Anything equal to itself, that means you can plug in whatever you want for x and get the same thing on both sides. Okay. Number 3, which of the following statements are true about real numbers? Real numbers, that was the key word. Okay, and so some of you pull out that chart that we made. Totally fine with that today. When we have the quiz next week, you won't have that chart. So just keep that in mind. And the correct answer for number 3 was B, 2 and 3 only. Okay, number 4. Formula V equals pi r squared h. Can be used to find the volume of a right cylinder. Did you have some geometry flashbacks there for a second? I did. Suppose the radius of the cylinder is twice the height. Which of the following formulas could be used to find the height of this cylinder if only the volume were given? Okay, so what did you plug in for r in this equation? What did they tell you about the radius? Twice the height. So your radius is really 2 times the height. So to find the volume, you would do pi times 2h squared times h. Whenever you square it, you have to be sure to square the 2 as well as the h. So you have pi times 4h squared times h. And you're solving for h by itself. So v equals 4 pi h cubed. So you have to get the 4 pi to go away. 5 by 4 pi. So v divided by 4 pi equals h cubed. To undo that cubed, you have to take the cubed root of both sides, which should give you b. That was a little more complex, so I wanted to work through that one. And then lastly, I want to know which of the following properties are used at some point in solving the equation. So what did they use for this first step? Which property is that? Distributive property. And then how did they go from here to here? They rearranged, so commutative. Okay, what about here to here? Substitution. All right, that's the new simplify. Then from this step to this one. So that the addition property of equality. Well, yeah, so they added this to that side and subtracted 9 from that side. Okay, which you might remember from geometry is addition property of equality. Okay, from here to here was substitution. From there to there was division. So the correct answer was C. Commutative, distributive, and substitution. Okay, how'd you feel about those? They weren't so bad? It was kind of overwhelming? No? Good. Hey, free response questions in the AP Mathematics world are always worth 9 points. It's usually divided into 2 to 4 different parts. The points available always earn a total of 9 points. We're going to work together through at least 2 free response practice problems, and we will look at the rubrics after each one so that you can begin to get an idea of what is expected of you as you answer these types of questions. Every quiz and every test that you take in Pre-AP Algebra 2, Pre-Cal, and AP Cal will be formatted in the same manner. Half the points will come from multiple choice questions, the other half will come from the free response questions. So half and half, multiple choice, free response. So the free response, pretty important. So we're going to work through the first one together, completely together. And as we work through it, we're going to look at the grading rubric for each piece. Okay, so this one says, assume that A, B, and C are integers, and that A does not equal 0. Additionally, remember that the definition of a rational number is a ratio between 2 integers. Part A, why does the closure property of integers not hold true for division? Explain why and provide a counterexample. That should be a question mark. Okay, so it says, why does the closure property of integers not hold true for division? Anybody have a guess there? What does it mean to be an integer, or what is an integer?
Real number.
Yep. So can you give me an example of an integer?
-1.
-1. Is 0 an integer? Is 1 an integer? 12. What about 1/2? No. Okay. So it's only like whole numbers, an integer, right? So why does that not hold true for division? What happens when you divide 1 by 2? You don't get an integer, right? So it does not hold true for division because if 2 integers are divided, the result is not always another integer. Because that's the essential meaning of what closure is, right? So I've explained why the closure property of integers does not hold true for division. But I also have to provide a counterexample. If it says counterexample, it wants specific numbers. So give me an example that's not the one I already used. That would be a counterexample for integers and division.
13 divided by 12.
13 divided by 12. 13 divided by 12 is a decimal. One 1.083 repeating. Okay. So this part of this free response question is worth 1 point of the 9 total for this one question, right? So you would get, if I were grading this, you would get a 0.5 point for explaining it to me and a 0.5 point for your counterexample. So if all you give me is the counterexample, all I got was a 0.5 point there. Make sense? Okay. Part B, show that when solved for x, the equation ax minus b equals c has a solution that is a rational number. So go ahead on your paper, solve that equation for x. Okay, most of you would get this answer right here. That's really fine. Okay, I put the other one there because that's the one Mark Sparks had on his. I don't know why, but it is. Okay, you can write it either way. Just the other one's more complicated. So, you would think that's what this question is asking, right? That's what I thought first, was that all I had to do was solve it. But this question is actually worth, or this part of the free response is actually worth 3 points. Okay? So it says, show that when solved, a solution, or has a solution that is a rational number. Okay? Well, we haven't said anything about rational numbers. What is a rational number? It's okay, you can pull out your notes. Or you can look at the very top of your paper. It's not up here, but it's at the top of your paper. What does it say? Remember that the definition of a rational number is a ratio between two integers. Okay, well, I've said what a rational number is, but how am I saying that that is a rational number? How do I know? Is that a ratio? How do you know? That's not a good question. Something divided by something else, right? So it is a ratio. I'm going to put C plus B divided by A is a ratio. So X is rational. Okay, so this would be 1 point, this would be 1 point, and it's worth 3 points. Have I said anything else? Have I given any more vocab words that we talked about so far that I haven't explained? Again here. have to be an integer. Right? It says a ratio between two integers. Have I said that this is an integer? No. Okay? C plus B is an integer. This is because why?
When you add two integers, you're gonna get another integer.
Yep, when you add two integers, you get another integer. So integers are closed under addition because integers are closed under addition. Therefore, C plus B and A are both integers. So if this were a free response question on your homework that I was grading, this is the rubric I would have. A point for correctly solving the equation with your work shown. A point for saying that a rational number is the ratio of two integers. And a point for saying integers obey the closure property for addition. Pay attention to all the details. Okay, part C, based on your solution to the equation in part B, explain the significance of the given information which states that A cannot equal 0. Okay, so go ahead and on your paper explain the significance that A cannot equal 0. grade yourself. This part C was worth 2 points total. So you get a point if you say a denominator cannot equal 0. And a point for if you say since the solution was C plus B over A, then the denominator A cannot equal 0. Okay? So you have to mention this right here. And you have to mention you cannot divide by 0. So the denominator cannot be 0, but you cannot divide by 0. You're starting to see how the grading works here. Okay. Part D, choose values for A, B, and C which cause the solution to the equation for part B to be a negative integer. What is the solution? Okay, so I'm going to let everybody do this because you're all going to get different answers when you do this. So choose values for A, B, and C which cause the solution to the equation from part B to be a negative integer. And what is the solution? Just another minute or so. Finish up and then I'll let you grade yourself on this part. Okay, so here's the rubric. You get 1 point for choosing integers and telling me what they are. So for example, A equals 5, B equals -7, and C equals -3. Okay, so 1 point for choosing numbers and telling me what they are. You get another point for choosing the right combination of integers so that the numerator and the denominator have opposite signs. So so that whenever you actually do the solution, you get a negative number. And you show your work showing that the numerator is divisible by the denominator, resulting in an integer solution. Okay? So as a reminder, part A was worth 1 point, part B was worth 3 points, part C was worth 2 points, part D was worth 3 points, for a total of 9 points for this whole page. Okay? So what I'm going to do is I'm going to let you flip this over and work through your class practice number 2. Okay, and I'm going to give you 10 minutes, which probably or may not be enough. Okay, but I'm going to give you 10 minutes to work on it. And while you're doing that, I'm going to bring you around, or bring everyone at some point today before you leave, the next unit. Okay, there's been a lot of kids the past 2 days that have had to go home to quarantine because kids have been testing positive for coronavirus. So in order to make sure that you have what you need, I'm going to go ahead and give these to you while you're here. So I'll bring those around while you're working. You can just stick them in the back of your sleeve, or if you have a binder, you can put them behind Unit 1. Okay. Go through this one. So part A was just solving. Here we go. Variables appear on both sides of an equation. There can either be one solution, no solution, or infinitely many solutions possible for the equation. Solve the equation and show your work. So for this part, there were 2 points possible. 1 point for correctly distributing the -2 on the left side of the equation. And 1 point for correctly solving after distributing. The correct solution should be x equals -1/6. Okay, the work is right here. If you missed a step, go ahead and fix it. Part B, suppose after solving an equation, a student ends up with a final equation 0 equals -3. How many solutions does the equation have? And explain your reasoning. So for this one, it was worth 3 points. If the equation 0 equals -3 is the final equation, then all the variables completely canceled out. That was worth 1 point, saying that the variables canceled out. We got another point for saying when this happens, there is no value of the variable that makes the equation true, because 0 can never equal -3. And you get a point for saying there is no solution to the equation. So 1 point for no solution, 1 point for saying the variable is canceled, and 1 point for saying there is no value of the variable to make that equation true. Part C, give an example of a complex equation that has infinitely many or all real numbers solutions. Make sure that the equation is complex, meaning that there are variables on both sides, and the distributive property must be applied at least once. Then solve the equation and explain why your solution shows that the solution is all real numbers. This was worth 4 points. So you get a point for having an equation that's complex with variables on both sides. Get a point for requiring the distributive property to be used at least once. You get a point for solving the equation to show that your final equation is 0 equals 0. And you get a point for saying the solution is all real numbers because 0 will always equal 0. Therefore, any number plugged into the variable will make the equation true. Okay, we have 23 minutes until lunch. So we're gonna do one more together, and then the last two, number 4 and number 5, will be what you'll do for homework tonight, okay? So, for number 3, I'm gonna put it up here. I'll let you work on it. We'll do 15 minutes this time. And then we'll go over it right before lunch. And then when we come back from lunch, you'll have that whole time to work on those last two, which will be your homework assignment. Okay. For response 3, we're simplifying the algebraic expression 3 times a minus 2b minus 2 times negative a plus b. Susie uses the commutative property, substitution property, and distributive property of real numbers. Without initially simplifying the expression, find the value of the expression when a equals -2 and b equals -3. Okay, this part was worth 2 points. So a point for substituting the values into the original expression, and a point for correctly simplifying to get 14. Okay. Part B, simplify the expression as Susie did. In each step of the simplification, state which property of real numbers is used. Like a 2-column proof that you did in geometry. This was worth 3 points. So correctly applies the distributive property by multiplying the first quantity by 3 and the second quantity by -2. A point for correctly applying the commutative property by switching the order of the terms -6b and 2a. And that you correctly apply the substitution property by combining like terms to get 5a minus 8b. Part C, evaluate the simplified expression from part B when a equals -2 and b equals -3. So 2 points. And substitute a equals -2 and b equals -3 into the result from part B. Which you can get this point even if your expression from part B was wrong. And then a point for correctly simplifying to get an answer of 14. Okay. Part D, suppose a student got the answer of 5 when working part A, but got the answer -1 when working part C. Is this possible? Why or why not? This is 2 points. If done correctly, this is not possible. So you get a point for saying not possible. You get a point for saying whether evaluated before it is simplified or after it is simplified, the numerical value of the variable expression should be the same. No matter what you do, simplify first or last, should get the same answer when the variables are plugged in. Okay? So for your response 4 and 5 are gonna be your assignment. You'll have 20 minutes when we come back from lunch. You still have 5 minutes now. If you just wanna take a brain break now, or when we get back, whatever, you do you. Okay?